Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on power transmission through nozzle. Even in our previous video lecture also, we discussed a problem related to this power transmission through nozzle. But this one is slightly different than the previous one. That's why I thought to solve this one. Here I have taken a question of the rate of flow of water through a pipe length of 2000 meter and diameter 1 meter is 2 meter cube per second. At the end of the pipe, a nozzle of outside diameter 300 millimeter is fitted. Find the power transmitted through the nozzle if the head of water at inlet of the pipe is 200 meter and the coefficient of friction for pipe is 0.01. So here we can write what are the data given for this question. So data given, first one, we can write the length of the pipe is given 2000 meter and the diameter of the pipe, capital D, let's write it 1 meter, and discharge, the rate of flow given here 2 meter cube per second. So this also we can write 2 meter cube per second. At the end of the pipe, a nozzle of outside diameter, this is diameter of the nozzle, this is 300 millimeter, or we can write this is 0.3 meter. Yeah, we'll find the power transmitted through the nozzle if the head of water at the inlet of the pipe is 200 meter. So head at the inlet, this is given 200 meter, and the coefficient of friction for the pipe F, coefficient of friction of the pipe, this is F 0.01. And what we need to calculate here, we need to find out the power transmitted. So power transmitted, we know the formula. This is rho g q h by 2dg. Okay, so this is the formula, power transmitted through the nozzle. This is rho density of the fluid, g is the gravity, q is the discharge through the pipe, and h equal to the head at the outlet of the pipe nozzle and diameter of the pipe, this is the gravity. Anyway, so this is the not this is the formula. 2dg will be not there here, actually 1000 power we are talking. This is not a 2dg. Yeah, it's much kilowatt. Anyway, now let's find out. So before going to solve, let's do the diagram for this. The diagram actually for this will be like a container will be there. From this container, the fluid is flowing through the pipe, and at the end of the pipe there is a nozzle is fitted to this one, and here this is the level of the fluid which is present in the tank or in the reservoir. And this reservoir actually a huge container actually this is. So volume of this container will be very large. So the fluid which is coming out from this container to this nozzle through this inlet, here we can see this is the inlet part actually. This is the inlet part. What I'm discussing, like the fluid which is coming out from this reservoir to this pipe, we won't get any kind of difference in this top level because it is a very large container. And this is the total length of the pipe L. This is the total length of the pipe, and this is the diameter of the pipe, capital D, and this is the nozzle part. This is the nozzle part, and this is the pipe, we can say. And here diameter of the nozzle is small d, and the velocity of fluid which is coming out from this nozzle, this is small v, and the liquid which is flowing through this pipe, the velocity of that, capital V. Okay, and the distance, the head, you can say the head at the inlet of the pipe is capital H. Okay, so this value capital H is given actually head at the inlet condition. This is given 200 meter from the surface level. Okay, now we need to find out the power transmitted through this nozzle. So first of all, let's find out the area of the pipe, capital A. area of the pipe equal to pi by 4 d square. So pi by 4 d square we can find out simply pi divided by 4, 0.785, 0.785, because diameter is 1 meter given, so this much meter square. Similarly, once you find out this area of the pipe, we can calculate the velocity actually. So how we can calculate the velocity? Now we know that q equal to av. So from here we can find out velocity equal to q by a. So this is q equal to 2 by this one. So directly I'll calculate. So 2 divided by 0.785, 2.54, 2.55, let right, this much meter per second. This is the velocity of the fluid which is flowing through the pipe. Now the next thing is, we'll go to the formula direct. Now here if you see rho g q h, this h is actually the head at the outlet of the pipe, in the sense outlet of the this nozzle condition, the head which is present at this position. So but here the data is given head at the inlet condition. We know that we can write, at the head at the inlet equal to the head at the outlet plus the losses happened, the head loss or loss of head during the fluid flow in the pipe. And here we can write the h outlet equal to, we can write h inlet minus hf. So this, put this value in this equation, this value put in this power equation. So let's write P equal to rho g qh, rho value 1000, density of water, so 1000, g 9.81, and q is 2 meter per second divided by 1000. Okay, so 1000 cancel. Now in bracket we need to write here h at the inlet condition. So h at the inlet condition is nothing but 200 and minus hf. So hf we know that 4f lv square by 2 dg, 4f lv square by 2 dg. So this is actually the major loss, we can say, or the loss of head due to friction. When the fluid is flowing through this pipe, there is some losses will be there, that is loss of head. This is the formula for this. And we can solve it outside, you can put the value directly, or we can write down here and we can solve it here also. So we'll solve it here and directly we'll put the value there. So this is 4f 0.01 and into L value 2000, I hope, yeah, 2000, and velocity value 2.5455 we got, 2.55 square divided by 2 into d, diameter 2, and this is 9.81. So let's solve this. This much square into 4 into 0.01 into 2000 equal to this much divided by bracket start 2 into 9.81 bracket close equal to 26.46. So this is, write down this value, 26.46. So here also we got this one, we can write 26.46 meter loss of head. Okay, now this one we need to multiply with this. So P equal to, so this much minus 200, let right, 173. 173 multiply 9.81 into 2, 3404.7, 3404.7 kilowatt. This is our final answer. Okay, this is the power transmitted through the nozzle here. Okay, so I hope you understand how to solve this problem. Anyway, this is very, very simple. Only you need to remember this formula, power formula, and the procedure how to solve it. So if you know the procedure, we can draw a diagram, a neat and clean diagram along with the data given and the formula required. So you can easily identify the answer. So I hope you clear about this problem. Still, if you are having any doubt regarding this, you can give a comment on the comment box. Thank you all.